Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's challenge is number of 1 bits given a positive, according to Leetcode, by the way, this is an easy question. I agree with that. Given a positive integer n, write a function that returns the number of set bits. In other words, 1 bit. Set bit is has a value of 1. In its binary representation, this is also known as the Hamming weight. Example, int, well, let's say the input is 11, okay? Now, if you convert that to binary, it is 1011, that's an 8, plus 2 plus 1 is 11. And as an output, we will say 3 set bits. Okay, there's actually, before we do this the right way, some programming languages, including Java, have a method to count set bits. So I think I think this will work. All right. I don't think that's really what they have in mind, though. So let's do it another way. First thing that we'll need here is a variable to hold, well, yeah, this is not so good. Let's call it count. There's there's a kind of a bit manipulation hack that if you and n and n minus 1, it'll take off the least significant 1 bit. So you can just keep doing that until n equals 0. And count how many times that you have to do it. But you're gonna. It's just not something that everybody knows, and so if somebody had to look at that, even though it's an easy problem, they're not going to understand what's going on. You can put a comment in, but there's, I think, a better way to do it because it's more understandable. So let's say for int I equals 0, I is less than 32, I plus plus, and we're going to shift. I don't know how many parentheses I'm going to need here exactly. If n, and we'll shift it each time. First time we'll shift it by, well, first time we won't shift it at all because I is 0, and then we'll shift it by 1, and then we'll shift it by 2. And so each time we are getting the next bit, the next significant bit, and eventually we'll be able to take a look at all 32 bits. So if we shift that, and then we and n with 1, that'll tell us if the least significant bit is a 1, or it'll return 1 if the least significant bit is a 1. And then we can do the comparison. Is it 1? And if it is 1, then we'll add 1 to the answer. Right? After which, I don't know why I have this all the way up here. After which, we'll just return the answer. Okay, so this is like what we did in the last problem, really, which is just to shift the bits one at a time, and we can take a look at them. Okay. For bit manipulation, you should be familiar with ands and ors, logic. Well, bitwise and, bitwise or, and shifts. Shift right, shift left. Let's try and run this. Compile error. What? Oh, okay. I didn't call it that. Let's call it count. Oh boy. Okay. All right, that's good. Submit. And it doesn't even increase the runtime. It doesn't even increase the runtime to do that. What is the well, I mean, I guess it's O of 1 either way. I mean, really, first way we did it, I guess we could say, yeah, I would say that's O. Yeah, it's O of 1. This is really O of 32, but O of 32 is the same as O of 1. Here, let's get a complexity analysis. O of 1, yeah. Okay, so that's it. Those are the things that you need to know to do bit manipulation. And hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.